For all real n, it is the case that n to the 4 plus 1 is equal to n squared plus root 2n, and so on, yada, yada, yada. From this, we may deduce that n to the 4 plus 4 is one of these statements. Okay, this is almost exactly the same as a question I had quite recently, within the last month or so. I believe it might have been submitted by a viewer, though. The alternate question I had said, take the expression n to the 4 plus 1 for natural numbers n, and it asked, when is that prime? And so, of course, I mean, I didn't immediately know this factorization. I kind of derived it by taking a detour through complex numbers. But essentially, all I really need to do here is figure out when these things on the right-hand side are wait a minute, is it? Oh, n squared plus 4. Yeah, okay. So maybe it wasn't n to the 4 plus 1 that I was given another question. Maybe it was n to the 4 plus 4. Okay, so n to the 4 plus 1 we're given is n squared plus root 2n plus 1 times n squared minus root 2n plus 1. Well, n to the 4 plus 4, I want to write this is, of course, n to the 4 plus 2 squared. And hopefully we can write it kind of like that, except yeah, it's funny they give us the decomposition of n to the 4 plus 1, but they ask about n to the 4 plus 4. N squared plus something plus 2 times n squared minus something plus 2. And I guess there will certainly be an n here and an n here. So I have n to the 4. I have n cubed times, I'm going to put a constant in front of both of these. It's a question of what I want to put there. Does it matter? Is it 2 root 2 I should put? Or okay, what happens if I put a root 2? This should not work. N to the 4. Those will cancel. N squared plus 2. N squared plus 2. That gives me 4n squared. No, so it's going to be 2. It's going to be like this. Okay, so if I expand that, let me just expand this. I get n to the 4 minus 2n cubed plus 2n squared plus 2n squared minus 4n squared plus 4n plus 2n squared minus 4n plus 4. And I get, I'm missing another n cubed term. this should be an n cubed here. So that's gone with that. Those three cancel and those cancel. Okay. So n to the 4 plus 4 is equal to n squared plus 2n plus 2 times n squared minus 2n plus 2. Okay. And we're asking about whether, when this thing is a prime. So for any value of n, for any natural value of n, we have a factorization. So the question is, this number is clearly always positive. And so for natural numbers, this is always positive. And so, of course, that's positive, meaning for natural numbers, this is always positive. So it's just a question of when one of these things is equal to 1. So if this is equal to 1, which natural numbers does this happen for? This happens when n is equal to 1. And I believe when n is equal to 5. 25 minus 10 plus 1. Oh, no, I guess not. Oh, yeah, I mean, it's increasing, right? What am I thinking? Sorry, when n is equal to 1, that's when we get 5 here. I'm remembering things from the previous time I solved this in the wrong way. Yeah, this is equal to 1 only when n is equal to 1. This is never equal to 1. Oh, wait a minute. Wait a minute. I wrote this wrong. Right. Okay. When this is equal to 1, that's the same as n squared minus 2n plus 1 is equal to 0. Wait, but this never happens. Is n allowed to be... Okay, so the answer is, yeah, when n is equal to 0. Hold on. What am I... What is going on? What is wrong with my head right now? Oh, sheesh. Oh my goodness. Okay. So this thing is prime only when n is equal to 1, which is option B. Yeah, and when n is equal to 1, this thing is equal to 5. Okay. If n is any positive whole number greater than 1, then that is a whole number greater than 1. That is a whole number greater than 1, and therefore I have a factorization of my number. But when n is equal to 1, that is equal to 1, and so it doesn't count as a factorization. Okay, there we go. The answer is B. Gosh, I never thought that having solved a problem before in the past would make solving it again more difficult. But I was misremembering certain things and obviously made a typo or two. I suppose the hardest part of this is taking the factorization that they give you like this and realizing that this is not the one you should use directly. It's nicer to write out the factorization of n to the 4 plus 4. Of course, they give you, this is kind of like a hint that this type of factorization can be done. But this is the best, this is the way that you want to look at this question. It's almost misleading to have given this hint to someone. But anyway, there you go. The answer is B. Thanks for watching.